Hello everyone, welcome back to my YouTube channel, the channel for mastering coding skills in Java and beyond. If you are new here, don't forget to hit the subscribe button and click the bell icon so you never miss an update. Today we are diving into another design pattern, that is factory method design pattern. It comes under the creational pattern category that helps us deal with object creation in a way that enhances flexibility and reusability. But what does that mean? And how can we apply it in our projects? Let's break it down. So we will be trying to understand factory method design pattern using the payment method example. First, we will be making the example in a normal way, but later on we will be converting our code as per the factory method design pattern. So in this diagram, you can see we have two payment methods, that is Google Pay and Apple Pay, and both have their own respective methods, do payment and process. And in my client program, so what kind of code we will be writing to process the payment using Google Pay or Apple Pay? So first we will be creating the object of each class, and then we will be calling their payment processing methods. So in case of Google Pay, we have do payment, and in case of Apple Pay, we have process. So we will be calling this way. So let's create the code quickly for the same problem. So here I have a class called Google Pay, and here we have a method public void do payment, and we have a logic to process payment, and finally we will be just printing payment processed using Google Pay, right? Similarly, we have another class that is Apple Pay, and here we have a method public void process, and we will be writing logic to process payment using Apple Pay. And once this logic is done, finally we will be printing a message payment processed using Apple Pay, right? And we have a client program, for example main, here if we want to pay through Google Pay, so what we will be doing, Google Pay equals to new Google Pay, and we will be calling Google Pay dot do payment, right? Similarly, if I want to pay using Apple Pay, and Apple Pay dot process. Let's run this program. So you can see payment processed using Google Pay, payment processed using Apple Pay. But think like, first of all, our main class, that is client program, which is tightly coupled with the rest of the classes, which is not a good approach, because in future if we want to add another payment method, it will be breaking open close design principle, right? Okay, so you can see in this diagram, so initially we had Google Pay and Apple Pay, two payment methods available, and now we want to introduce credit card, right? So for credit card, again we will be creating the object of credit card, and we will be calling credit.pay. So in this way you can clearly see, like, we are making client program dependent on the rest of the payment method classes. And one thing more, each class has their own different method. For example, in Google Pay we have do payment, in Apple Pay we have process, in credit card we have pay method. So our client program is completely dependent on these payment method classes. So in future, if we want to make this change, so we will have to change the client program, which is not a good approach, right? So let's jump into the code side for the same replication. So for example, I want to add credit card. So here credit card, and we have method pay, and we will be writing logic to process payment using credit card, and finally we will be printing payment processed using credit card, right? And in our main program, if we want to use credit card, and finally we will be calling credit card dot pay, right? So as I already mentioned, so this is not a good approach, because so we cannot expose creation logic to the client. So every time when new payment methods will be introduced, so we cannot modify the client program every time, right? So how to overcome this problem? So let's move to the next step. So before moving to the actual factory design pattern, so first we will be making uh, these payment method classes under a common interface, so that every class would be having the same method. So how we can do that? So to make these classes common in some way, so we will be inheriting these three classes from a common interface. So I will be calling it payment method. And once these classes are implemented from this payment method, so you can see, so inheritance always comes with is a relation. So you can say credit card is a payment method. Similarly, Apple Pay is a payment method. Google Pay is a payment method, right? So the single parent can point all these different classes. So when we will be calling it from client program, so we will be pointing our child classes using parent reference. So payment method GPay equals to new Google Pay, right? Similarly, payment method equals to new Apple Pay. Similarly, payment method equals to new credit card, right? But still, uh, this thing doesn't resolve our problem, which is like we are exposing the object creation logic to the client program, right? And again, for future enhancements, so if we will be making the changes here in client program, means we are just breaking, or we are just violating the open closed principle. Okay, so before moving to the final factory method design pattern, so let me replicate these things into coding. So here I am going to introduce new interface, that is payment method, and in this payment method, so we will be having method do payment. So I need not to mention abstract and public along with that, because public and abstract is by default with interface methods. So we need not to mention this thing here. And all my payment method classes will be the implementation of payment method. So if I do implements payment method, and the method name would be do payment, all right? Similarly, credit card implements payment method, and the method name is do payment. And Google Pay implements payment method and do payment. So now these are the child classes, and in main method, what I can do is it would be payment method. It would be payment method, and we need to call do payment. Similarly, payment method and do payment, right? So in this way, we have make some similarity for all these payment method classes, but still client program relies on the concrete classes of payment method. So every time if some new method is introduced, so we will have to create that object here, which is not a good approach. So ultimately what we want to do, we just want to make this client program independent of the concrete implementations. We just want to remove this tight coupling in client program, so that anytime new enhancements are done on the program, so client program shouldn't affect. So it should work the way it is already working. And to overcome this problem, so we will be following the factory method design pattern. So let's jump into that pattern. Let's try to understand that pattern using the diagram, and then we will come back to the coding side. Okay, so in this diagram, you can see the right side of this diagram. So this part is already implemented. So we have one interface, and all our payment method classes are implementation of payment method. So basically, a common reference can be used to point out these classes, right? But before moving to our main program, so we have introduced a new class which is payment method factory class. So basically, factory method design pattern relies on this class, and our client program will be dependent on payment factory method, and our client program will be dependent on payment method factory class, and it will not directly dealing with our concrete payment method classes. So you can see in payment method factory, so we have a method or get payment method, so which will be responsible to give us the appropriate object of payment method. And as all these uh, payment method classes are implementation of payment method, right, payment method interface, so the return type would be the parent of these concrete classes, right? So in this factory, what we will be doing, so we will be just passing some string or some flag from where we can identify which uh, payment method is required. So for example, in this case, we are passing a string type. So if type would be Google, then we will be returning the object of Google Pay. If the type is Apple, we will be returning the object of Apple Pay. And in future, if we add some new type, so we will be adding that just here in payment method factory class. So we will be just adding one condition here for that new type, and we will be returning the new payment method. So for example, initially we had Google Pay and Apple Pay, and later we introduced the credit card. So we just need to mention those things here. So there we need not to make a lot of changes here and there. And ultimately, if I come to the client program, so you can see we just created the object of payment method factory, and by using this, so we are just calling get payment method, and just by passing a string variable what kind of object we need, we will be getting the object back, and we can call the do payment method. So similarly, for example, I want to use Apple Pay, so we just passed this string here, and we will be getting the object, and which is pointed by the payment method, the interface or the parent of these classes, and by using the common method do payment, we can process the payment. So let's jump into the coding side to understand this thoroughly. So here I am going to introduce new class, that is payment method factory, and this class contains one method which is of payment method type, and here get payment method. So for example, I have a type here. If type dot equals Google, then payment method equals to new Google Pay and a return payment method. The other use case, else if type dot equals Apple, here payment method is Apple Pay and return payment method. Else if, for example, we added new payment method, that is credit card. So credit, and in that case we will be returning the payment method of type credit card. And we can do one thing, we can mention one else case here. So return null, right? Or we can return throw illegal argument exception, invalid type. So I just need to mention new invalid type entered. So if there is no matching case, then we can return illegal argument exception, invalid type entered. And from client program side, so as we had tightly coupled creation of objects, so now we are not depending upon the concrete classes, but what we can do, so we can have payment method factory equals to new payment factory, and here we can call factory dot get payment method Google, right? Or if we need Apple Pay object, so what we can do, factory dot get payment method Apple. And in future, if we introduced any other payment method, for example credit card, PayPal, or any other method, so what we can do, so we can just call the factory method to get the instance, and further we can call for the payment. Because whatever the new method we will be introducing, so by using open close design principle, so we will be introducing any new payment method that would be the implementation of payment method. So the way we created credit card, Apple Pay, or Google Pay, right? And in main, so here we have, what we have done is like in factory pattern, we create object without exposing the creation logic to the client, and refer to newly created object using a common interface. So which is like the return type of get payment method, so which is the interface, so payment method. We can make a change here just to make the things little more easy. So in payment method factory, so we can make this get payment method static. So by this way, we need not to worry about creating the object of payment factory. So I can just comment this code, and here, so we can directly call payment method factory dot get payment method. So as we can call the static methods directly with class name. So this is the change we can make here. Yeah, that's all about the factory method design pattern. And here our solution or our client program is completely depending upon the factory method, where he has to pass some flag, and on the basis of that flag we will be getting the relevant object back that can be used for further processing, right? And that's a wrap on factory method design pattern in Java. I hope this video helped you to understand how to implement this pattern in your projects. If you found it useful, give it a thumbs up and share it with your friends. Don't forget to subscribe for more coding tutorials, and let me know in the comments what topics you would like to see next. Until next time, keep coding and let's code together. Thank you.